Hi, it's Robin. Last time we looked at this Penultimate+2 cartridge from TinyMon Software, and the future was 8-bit, and we focused on the more than 200 games and the various menu and boot features that are built into this cartridge. Today, we'll be looking at all the rest of the functionality, and there's a lot of it, from diagnostic tools to programming utilities, RAM expansion, and file browsers. Now, even if you don't plan on buying this cartridge, you might still find the programming examples I'll cover today useful or interesting, or the explanation of RAM expansion, so check the chapter index if you want to jump around the video. So here we are at the main menu. I explained this in the last video, so watch that one if you want to see all the shortcuts and so on. We'll spend a lot of time in this utilities menu, but first we'll jump ahead to the file browser and look at the features that more casual users might want, such as running games that aren't built into the cartridge, before we get deep into the programming examples. So just go into the file browser, and it's loaded the directory from my micro IEC drive that's plugged in the back. Now, this is one I've had for years and years that I bought from Jim Brain at Retro Innovations. The future was 8-bit, sells a much prettier looking drive, but functionally, they're very equivalent. It allows you to use an SD card as a Commodore disk drive. It's not really a 1541 emulator. Instead, it acts more like a big hard drive, such as those made by CMD. So this is actually the SD card I've been using for years while making my videos, and it's full of junk. You might notice some files from old episodes here, but we can just browse through here, and over on the right you see it says directory. So I'll press return. This is my VIC folder, or VIC directory. And here's some programs I put in a VIC folder. I actually did this on my Mac earlier. Down the bottom left corner, it says RAM Auto. And if you want to choose a particular RAM configuration, you can cycle through them all here. But most of the time, Auto works fine. And based on the load address of the file, it'll detect automatically what sort of RAM expansion. As I said, it usually works fine. So let's look at a few here. So here we'll go into fire.d64. Just press return to enter the D64. And here's the boot file fire. Just press return. And it'll say loading with 3K RAM expansion. And auto detected that and successfully. This is a game published by Double Sided Games a while ago. I got this back when I worked on the Realms of Quest RPG review. I should plug in a joystick. By Rainer Kapler. So the idea is that you just drive the fire truck over to wherever the burning fire is and move it on top of the X. Actually reminds me a lot of Ghostbusters in that you have to drive on an overworld map and then you actually do the driving. There we are. And now we should have arrived. And now we have to, whoop, over there, catch the guy. So it is a very simple game, but it works on a 3K VIC. I think it's kind of fun. Oh. That's a lot of people jumping over there. Well done. Okay, so you get the idea. So I reset the computer. We can quickly get back into the file browser by pressing B. Back into the VIC folder, Realms of Quest 5. Just so you can see a disk-based game that's absolutely maxed out for RAM expansion, or requires maxed out RAM expansion. Big file. Okay, and there we go, boot. Loading with 35K boot. For these really big games, it is a good idea if you get Jiffy DOS for your VIC-20. That's available from Jim Brain at Retro Innovations. I did a full review of this game a few years ago, so check out my video, link in the video description. Quick start. This is probably the biggest VIC-20 game ever made. Huge RPG. And here, move, exit the town. And there we go, moving. Let's walk over to the sign. And press return. And read the sign. Reading the sign. Vivat Suprema Domina Autumn Riviera. That's some Latin. Okay, moving on. I already spent a long time playing games last video. Should keep this quick. And as a shortcut, there's this option, File Favorites. So yeah, you can use B to get into the file browser as a shortcut. There's also File Favorites, for which you can just use the menu or press F. And what this does is load specifically from a folder called PU+2. If you make that folder, then you can just quickly get into your list of favorites. So here's a few more I've put in. Here's 1010, and I believe this is a 0K game. Yep, loading with 0K, no RAM expansion. Parallel Universe 1010 by Jeffrey Daniels. Jeff's a great guy. This is a pretty amazing game, 1010, that he made. Definitely check it out. It's level 1. So on the left side, you're that red dot, and on the right side, you're the blue dot. And the joystick moves both together, as it says, parallel universes. And what you have to do is get on that white dot at the same time. There. But the mazes are different on each side, so you have to kind of figure out how, like I'm pushing up, and the red guy can't move up because there's a wall there. So here I'll move up there, and I can move down. There we go. And I can move down. Oops. How are we going to do this? There, now I can move up. There we go. And if you solve 3 levels within the time allotted, then you go on to the next level or phase or whatever. It's a really fun game. Kind of mind-bending. Well, that's not going to work too good, is it? Oops. Now I did it. Ooh, there. No. High score. I should mention that Jeff sent me this VIC-20 Quick Reference Handbook, edited by Jeffrey Daniels. And it's a pretty amazing reference book. So if you want to program your VIC-20, it's got like what, memory maps. This is like the super chart from Jim Butterfield, but done up even nicer, where all the different representations of the decimal or hexadecimal values are shown. Pages of that, all the basic commands, character codes, screen addresses, all kinds of pokes, music. I guess I should do a whole video just on this book, shouldn't I? But just to make you aware of it, and I'll put a link in the video description for that. The VIC-20 Quick Reference Handbook. Yeah, just a fantastic piece of work. Thanks for saying that, Jeff, and thanks for all the games you've made and all the great stuff you've done for the VIC-20 community. Again, reset. Favorites. I've got things like TinyMon here. That's also an unexpanded VIC program. So there it is by Jim Butterfield. Oh, that doesn't do anything good. Disassemble doesn't work. We can look at memory at 1000. Oh yeah, type of range on this one. There we go. I'm not going to demonstrate those right now. I'm just showing how, if you've got any VIC-20 programs you like that weren't built into the cartridge, just press F for favorites. And there they are. Did find one place where the auto boot didn't work. Robin 10 line. This is that 10-line adventure I wrote in BASIC a while ago. Press return. It's loading with 35K. And then it just kind of crashes, lists, there's no program there. Okay, but this isn't really the cartridge's problem, or at least... Okay, so there's the 10-line adventure. If you load the program, comma 8, comma 1, which is what I think the cartridge is doing, then there's no program. Well, it just shows the directory because that was in memory. So what you have to do is load the program just comma 8, and what that does is forces a relocatable load to the beginning of BASIC on whatever Commodore machine it is. And on the VIC-20, that can vary, but actually, if I remember correctly, yeah, there's the actual game. 10 lines of very dense BASIC code. I did a video about this. It's a 10-line text adventure game. Again, check the video description. I'll put a link there. Anyway, you have to load comma 8 to relocate the memory, because I think I actually coded this on the Commodore 64 first, and then just ran it on the VIC-20 after. What a cheater I am. So the trick is now just save it, again, that you've loaded it, 10-line adventure fix, for example. Okay, so that's saved. Reset. Go into the favorites. Robin 10-line adventure. Okay, and that's the file that failed. Now here's the fixed one that I just loaded. It all relocated it into memory. Now the RAM autoconfig should identify it properly. So I'm just going to load that second one, return. Loading it with 35K. You are in a cave. Okay, north, you walk. You are in a hall. East, you walk. You're in a pit. Look. There's a chest. Open the chest. Oh, look. Chest. Closed. Open. Chest. North. You're in a lake. Look. Look. Corpse. A key. Get key. South. Look. Open chest. Opened. Look, chest, sword, get, sword, north, west, east, north, south. I do not remember how to do this. West, south. In the pit, where do we go? East, south, west. You're in a hall. Look. Oh, there's the dragon. Fight dragon. Cannot do. Kill dragon. You won. Yeah. Okay, well, there's the whole text adventure. Oh, yeah, one other thing. File favorites, if you start that up on a PAL machine, it says file favorites, like F-A-V-O-U-R-I-T-E-S. Okay, so here's the so-called NTSC spelling, the American spelling. And here on my PAL VIC-20, thanks to Anders Carlson, if you go down, you'll see File Favorites has the U in it. Now, this is very cute. The problem with it is that I'm Canadian, we're NTSC, but we spell favorites with a U. So NTSC does not only mean USA. NTSC also means Canada, and actually it means Mexico. And it sort of means Japan, too. Anyway, I appreciate the joke, but I do feel a little bit marginalized. This is not my favorite feature. Okay, back to my NTSC machine. Finally, getting on to the Utilities menu, which can be shortcutted to with U. And we'll just work through these, and I got little examples of each one. Starting with VICMON at A1000 hex, A000. Okay, so it starts up in BASIC, and you might think nothing's going on, but a machine language monitor is in the ROM, and we start it with A00 hex, so that's the same as 10 in decimal times 4096, if that's easier for you to remember. I don't know that will be. Or just sys 40960. And here we are in VICMON. So for example, we can examine memory with the M command. And this shows that we currently have 1B in this register. This is actually the combined background and border color for the VIC video chip, and the default is 1B. 1 is the white background, and B is actually 3, which is the cyan border, that kind of blue border, plus 8 to set the high nibble. It's actually kind of weird. It's actually the high nibble there is the white background, and you have 16 choices for that. This is binary, by the way. And then there's 1 bit dedicated to whether the background is reversed or not. So basically that stays 1 all the time unless you have a reason to turn it off. And then there's 3 bits dedicated to the border color. So there's only 8 possibilities there. This is 3, which is the cyan border. So if we want to change that from cyan to green, then instead of color 3, we put color 5 in there, which is 2 more. Anyway, the result is you put 1D in this register, and it'll change the border color to green. Commodore 64 makes this all a lot simpler by separating out the registers instead of packing so much into these color registers. But we actually can't press return right now. If we do, it'll also enter these bytes into memory, these following bytes. And that'll actually crash the machine. I don't feel like doing that right now, so I'm just going to erase them. And when I press return, it should put 1D in location 900F, changing the border to green. There we go. It worked. Okay, so maybe we'll make a little program we can assemble with this. And this is just like the machine language monitor that I use on the Commodore 64. It has a simple immediate assembler built in, but it doesn't handle labels or anything like that. So we can load location 900F, that's the border. Clear carry, and then we can add with carry the number 1. So it'll just take whatever value is in this combined background border color, increment it by 1. Oh, it didn't accept that. That's because you have to put not only the immediate mode, but the hex sign, the $sign to indicate hex 01. So it's not the most user-friendly assembler, but it works. So we're going to increment that by 1, and then we're going to AND it by 07, and that will mask off the upper 5 bits, because I just want to change the border color here. Did I already say that? That's what this program is going to do. And now I'm going to OR in color 1, which is the white, and set that bit 3, that turns on that reverse mode, and we don't want to fiddle with that. So we're going to mask out the high bits and then set them the way we want here. store it back in that register now that we're done. And we're going to jump in our program back to location 2000 hex. Okay, we're ready. And this is going to flash the screen. Look away if you're sensitive. Well, it won't flash the screen, just the border. There we go. And now at very high speeds, the border color is changing. That's just a short example of what you can do with a machine language monitor. Actually, you see a little bit of interference traveling down the screen. If I hold down stop, it makes that interference a lot bigger. And that's actually just the, you can visibly see the operating system interrupt handling that scans the keyboard and so on. You can make it burn more cycles if you hold down stop. Okay. And if you want to get out, you can hit stop restore. And then you just have to sys 40960 to get back into the monitor if you want to do that. We can disassemble and see the program we just typed in. And there it is. Okay, moving on. Again, we'll just do a quick tour of everything. U for utilities. Now we'll try running this VICKIT 4+5. Okay, now this is a 4K, well, VICKIT 4 is a 4K EEPROM, or originally it was, that contained firmware that allows the user to load or save from cassette at turbo speeds up to 6 times faster. And also it contains a machine code monitor, hexadecimal calculator, and link commands to use with something called VICKIT 5. And VICKIT 5 is another 4K EEPROM, or at least it was. Now it's just built into the Penultimate+2. It contains a 6502 assembler. And VICKIT 4 and 5, you can use 4 on its own if you want, but 4 and 5 together are a complete, if kind of strange, assembly machine language development environment. Okay, so again, it doesn't look like anything's happened, but there's a bunch of commands. I'll link to PDFs of the instructions for this so you can go in more depth if you want. It adds a bunch of extra commands. You just type back arrow and then O, and that actually disables it. So to start again, sys 40997, and you can get into a machine language monitor with back arrow X. And this is like the third machine language monitor we've seen today, or fourth even. Third one built in. This one's pretty minimalistic. But yeah, you can, you can dump memory with the M command and so on, but it doesn't have a disassembler. That previous VICMON is better, in my opinion. Okay, but we'll drop back out of the monitor. But the real reason to use this is that there is this assembler in VICKIT 5, and we can use it just like a basic program here. Just make sure we don't have anything in memory yet. Line 10. And you can set the origin for your machine language program. So use something like 7000 hex, way up towards the top of memory. I'll just show you a quick example. And if I just want to print the letter A, you could load A with number 65. And line 30, we want to jump to FFD2, that outputs a character to the screen. And line 40 would be RTS, and that should be our machine language program, or our assembly language program. So to assemble it, go back arrow E. These are all these extensions that have been added to BASIC, but you are using the BASIC editor. Okay, E will assemble. Now this funny prompt is the number of blocks you want to reserve for object code, and I just press return. Okay, so it tried to assemble it. So it passed execution to this VICKIT 5, but I've got error 9 at 2. And rather strangely, it doesn't use the basic line numbers, but uses its own line numbers. So do I move? No. So error 9 at 2, line 2, is this one that has load A with 65. I don't know why they didn't use the line numbers we're providing. That would make it a lot easier to find errors rather than mapping it, but whatever. Okay, error 9 means there's an invalid symbol in line 2. And as we've learned, line 2 is actually 20. So this is really weird, but in VICKIT 5 assembly language, you do not use the number symbol for immediate mode, even though that's super standard. We actually have to get rid of that. Actually, if you even look at the assembly language it generated based on that load A65, AD is the hex for the load A opcode, but then just did like 16 bits worth of EEEE. I guess that means that wanted to interpret this as a 16-bit value, but it didn't. It couldn't. Anyway, so this is very bizarre. But I'm just going to change line 20, and most assemblers will interpret this as a 0-page location, 65, but not this. That's immediate mode. It's going to load a literal 6.5 into the accumulator. Okay, so we'll try assembling again. Back arrow E. Block. Okay, so now it says there's no errors. Well, yeah, it prompts to move. I'll explain that in a moment. If we went ahead and executed now, we would get another crash. So now we see that load A65 is properly being assembled into A9 as the hex for immediate mode load, and 4.1 is hex for 6.5 decimal. So that's right. But next I wanted it to assemble JSR FFD2, and instead it's assembled that to this nonsense. 1CD2, this should be 20, and that should be D2FF. Anyway, it's, again, this assembler is wrong, but it doesn't even detect the error. So this took a while to figure out, but the problem is it does not like you using absolute addresses like FFD2 as a parameter. It wants you to use a label. So I'm going to add line 25. Character out is equal to FFD2. So that's just assigning this hexadecimal address, which is just a kernel ROM call, and assign it to this character out label. And now I'm going to edit line 30 to jump to subroutine character out. Okay, so now that's going to be the equivalent of FFD2, and it should be able to parse it properly. Back arrow E. Yeah, and now that looks like the assembly is correct. And do you want to move it? That means do you want to move it into the correct part of memory? I'll say yes. And now we can sys that at location 7, just like we assembled it here to location 7000. So that's 7 times 4096. That's the decimal equivalent of 1000 hex. Hey, here we go. There, it printed A on the screen. Okay, so I had a longer example for this, but this is a fairly bad assembler. But anyway, if you like it, I don't actually know of a better native VIC-20 assembler. So, you know, maybe you want to mess around with this. It does have a non-standard syntax. It is really quirky. It was still kind of fun to figure out. Again, check the video description to links to the manual, which aren't all that great, by the way. But, you know, it is usable. Okay, moving on. Back into utilities. And now, Super Expander. Okay, I've used this in a video or two before as well. Again, link in the video description. And I also have a link to the manual for this one. But basically, a Super Expander gives you some extra basic commands that some people think should be included to start with, such as graphic commands. This turns it into kind of a high-res graphics mode. And you can set a color command. This is just one that they had in the example. So that sets the various color registers. Line 120. And here we're going to draw in color 2 from pixel location 312, 312. Okay, well, I said pixel location. This has kind of like a virtual coordinate system. They're not real pixels. Instead, the screen is considered to be 1024 by 1024 units. in size. And that's far, that's like a 1K screen, which of course the VIC-20 is not at all capable of displaying, like 1 megapixels. But it used it. So kind of a weird choice they made back when. So anyway, but you can string together from location 312, 312 to 712, 312 to 712, 712 to, this is just string together a bunch of lines, 312, 312. Now it's just going to make a square. Line 130, circle in color 2 with a center of 512, 512. That should be the middle of the screen. And a radius of 200. Well, not really a radius. Yeah, a radius, but both, you can specify both X and Y. 140. And you can also, because it's a bitmap screen, you can't just print to it. They give you a character command. Character coordinates 16 down, 3 across. And we can do something like, oh, great art. Okay, where's my mistake? 312 to 712. Oh, I missed one here. 712 to 312, 312. Okay, let's try this again for the first time. There we go. Great art. It's a square with a circle inside. Yeah, and to get out of the high-res mode, just hold down stop and tap restore, and there's your program. Here's one other quick example. So if you don't like that weird 1024 by 1024 coordinate system, you can kind of work around it like this. This took me a little while to figure out. If you make this function formula here, 3.2 plus 6.4 times p, and if you use this function and pass in the pixel coordinate you want between 0 and 159, which are the actual screen chords, both X and Y, it puts the VIC in a 20 by 20 screen for this fake bitmap mode. So if you give it the pixel coordinate from 0 to 159, which is 8 pixels each times 20, that's 160 possibilities, then that will plot the exact pixel that you want. Well, here, I'll finish the example and you'll see. So again, we'll just put graphic mode 2 on, color of 1, 6, 0, 10. Line 30 for X equals 0 to 159. We're just going to plot across the screen from X, 0 to 59. Line 40, Y equals, and we'll take the sine of X divided by 20, and we'll multiply that by pi, and then we'll multiply that by 80 for the amplitude, so it'll cover the whole screen, and we'll offset it by 79. Line 50. Now we can draw the point in color 2, and we'll do that with function p that we defined above, pass in X, and also function p will pass in the Y that we calculated on line 40, and 60 is next. Okay, so the reason we're dividing, you have to convert the sine function expects radians, which are based on pi. So basically, we're just shortening the period by dividing it and then multiply it by pi so that we're passing a full range into the sine function as X goes across the screen. Well, the sharp-eyed people will notice I was testing you. Of course, I did that by accident. Oh, no, on purpose. I should have just put an actual pi symbol in there. I don't know what I was thinking. Anyway, so I'll change it to that little guy waving there. That little camel guy. There's the pi symbol. That's shift and the up arrow. And now we'll run that. There we go. Yay. What? illegal quantity. Oh, am I ever having a hard time today? Let's try period of 79.5. Must have pushed it right up against into like 0. Come on. There we go. Oh, nothing's easy. So it doesn't seem to have like error checking, boundary checking in this. So if I tried to put, I must have pushed it and had a negative coordinate there probably. Just slightly less than 0. Okay, so anyway, that's how you can make some like graphs or something like that. If you don't want it, there, let's do less waves here. Well, I mean more. That's almost useless, eh? $32. Okay, if you want to plot more dots, you could set the step for X, like go step 0.25, and it'll do 4 times as many dots there. And it'll take 4 times as long to draw, too. But you can see that it's dropping each pixel on a real VIC pixel each time. Beautiful. Okay, moving on. And reset. Again, go into the utilities and try Basic 4. Loading Basic 4. Okay, so this is, as it says, Basic version 4. This is what was put in later Commodore PET computers. For various reasons, the VIC-20 and the C64 ended up with version 2. Probably, at least on the VIC, it was a cost savings, minimized the ROM size. And on the C64, well, it probably wasn't so much cost cutting as lack of engineering time. They really rushed the C64 out. But they made a lot of good choices with the C64, so I'm not going to complain. Okay, so what this really gives you is improved garbage collection for strings. I talked about that in depth in a video about Dungeon for the Commodore PET, where a bug was caused going from Basic 2 on the PET when you ran Dungeon on Basic 4, because of the different string handling, it caused a weird glitch. So we won't look into that, but this does give you a bunch of kind of interesting disk commands. If you type catalog, it'll show my disk directory. And also if you type in directory, it's the same command. It shows the disk directory, and both of those can be abbreviated C-Shift-A or D-Shift-I. And it shows my messy disk directory. And the nice thing about this disk directory is that it's non-destructive. You might know that if you load, it's perfectly fine to load $8, but that erases the program in memory. And so if you want to check your disk for a file, but you have a program in memory, then, well, that's no good. So that's where this catalog or disk directory command comes in handy. And you can also do selective things like CA and put in quotes T*, and it will only show the files or directories that start with the letter T, for example. So that's handy. Now, an unfortunate thing is that there is no support for just quick disk commands, which are really handy. So unfortunately, stuff to type in long form like this, if I want to change my disk directory to test, I have to send it as one of these open commands. But then once I've done that, you can see that we're in my test folder here. Okay, so if I make a little program called, hello world, and we run that. Here's some of the other commands we have available. Disk save. We could call it hello. Okay, so that's saved. If we do a disk directory, you can see that we now have a program file called hello on this disk. This was another one I was messing around with, I guess. Test1. And now if we get rid of the program, we can deload hello. And there's our program. There's a copy command. So we can copy hello to test2. Now you see our hello file has had a duplicate made called test2. And if we don't like that, we can go rename test2 to just maybe plain test and do a catalog. And we'll see that now test2 is now called test. And if we want to get rid of it, we can even type in scratch test. It asks, are we sure? Yes. And now we can do, I'm in the habit of using that catalog, but here, D-Shift-I is directory. And you can see that test is now deleted. That's what scratch means. If you go print, or a disk status string, it tells you if everything's okay. But if we do something here, let's try copy junk to blah. Okay, it says it's ready, but I know that should be an error, so we'll print DS string. Actually, the green light is blinking on my micro IC in case you can't see that. That means there's an error. And now we can print DS string, and it'll tell us that there is an error, file not found. Or you can also print DS and get the error number alone, which is 62. That's easier to check for in a program if you're writing a basic Ford program that wants to check for disk errors. So those are the kind of commands that are built into Basic 4. Again, I'll have a link in the video description to a lot of these commands. There is a little monitor built in that's once again available, but it's, we can dump memory. There we go. But it has very few commands. And of course you can look at the registers, but that's about it. It doesn't have like a disassemble command. It just doesn't understand. It puts a little question mark there. X to exit. Okay, that's Basic 4. Again, moving on. Utilities. VIC Forth. Now, if you remember some time ago, my friend and patron Paul Pridham, who is the programmer behind Death Road to Canada and Chillaxian and Punch Quest and a bunch of other great modern indie games, he helped me make a video about Forth 64 for the Commodore 64. And we figured out how to write a Forth version of 10 print. So my friend and patron Michael Doornbos did a slight adaptation of Paul's Forth 10 print to work here in this VIC. So let's try it. So again, check the video description if you want to see my long video about C64 Forth with Paul. 10 print, begin 49152 40960. So this is making a program called 10 print, and we're going through all these memory locations. And Forth is weird. You put everything in backwards. This is like a do loop through all those locations. And we're going to AND it with 1. It's like reverse Polish notation. Okay, and we're going to just take the low bit of ROM locations and then get a character in memory, add it to 205. And then we're going to emit it to the screen in a loop, 0 until, and semicolon. I hope I did that right. Okay, yes, that means we did it right. And now we're going to do 10 print. There it is. You can hold down Control to slow it down. That's just built into the operating system print output character. Control slows down the output. There it is. A lovely 10 print maze made in Forth. Actually, don't even know how to, if you can escape that. Stop restore doesn't seem to work. Okay, that's enough Forth. I'm still so dumb at that. Watch the video with Paul. He is a super whiz at Forth. Okay, next is VICTERM, a terminal program. So for this, I've asked Michael Doornbos, who is a huge supporter of the channel, and he's our resident plywood expert. He's kindly agreed to do a demonstration using VICTERM to connect to his KIM-1 clone, which is the system made by MOS before Commodore bought them, and it came before even the Commodore PET computer. So take it away, Michael.
Michael here. We got our VIC-20 hooked up to a PAL-1, which is a clone of a KIM-1, RS-232 to the VIC-1011 cartridge, which was available back in the 80s to hook up your VIC-20, Commodore 128, and 64 via RS-232 and use it as a terminal. So if we hook up our Penultimate+2 cartridge and get started, we can turn our VIC-20 into a terminal. Go down to the Utilities menu and start VICTERM. And we need to set our baud rate. And we go to the next page, and I'm going to turn off character conversion. I'm going to leave it in 40 column mode. It's kind of hard to read, but it is convenient to be able to use it in 40 column mode. We hit T for terminal on. If we hit reset on the KIM, we get a nice interface into our serial terminal on the KIM-1. I've got some programs here at 8,000, and if we start them, there's a couple of them on here that are really fun, basic. That's actually Microsoft Basic Forth EWAS, which is WASMON. So if you're watching Ben Eater's videos lately, you can play around with WASMON that he's been doing a deep dive on. So let's start basic. We'll do the default memory size. Terminal width, I'm going to make 39 because that'll keep it from pushing our carriage return down as it gets to the end of the line. So it'll do a line feed and a carriage return, which we don't want because I'm going to do our 10 print, which is one of Robin's favorite programs. I'm going to make a slight modification to it because the character set is different on the PAL-1/KIM-1. So it looks just a little bit different than what we've seen before. And there we have it, a terrible version of 10 print on a KIM-1 interfaced with a VIC-20 via VICTERM. Back to you, Robin.
Okay, thanks, Michael. Definitely check out his website at iamapenguin.com. And he's written lots of great blog entries about his 8-bit projects, both hardware and software there. Back into Utilities, CBM Command, or Commander. Okay, so this is a program that lets you, it's kind of like a file commander, a little bit in the sense of Norton Commander, and it works on the VIC-20 even. This was written about 10 years ago, I think, by Peyton Bird and Greg Kane. The VIC-20 version, of course, is probably the most limited of all these, but does work. The commands are a bit weird on it. You use the cursor keys to scroll around. So if we look at that test directory, now return doesn't get you in. You actually have to press Shift+ to enter it. And now we can see that test file, and there's hello. And you can mark files if you want to. I won't mark, here I'll mark that one, hello, and we can delete it with, down at the bottom it says 8. That means press F8, Shift F7, delete. Are you sure? Yes. Okay, so that's deleted it. And to go back out of a subfolder, you hold down Shift-. So that's how you browse around. It also supports a second drive. If you see down at the bottom of this light blue or cyan, it says left, just down below this line, it says left. You can actually, there's 2 windows, but the VIC-20 screen is so small, you can only see one at once. But if you press cursor right, it'll go over to the right panel. Now, the major limitation here is that you really need a second drive, like device 8, for example, on the left, and drive 9 on the right, to be able to do copying files and so on. Now, on like a Norton Commander or something, you could have both panels pointing to different parts of, say, the C drive. So, for example, here, I'd be, let's go back into that test directory. I'm on the left right now. I'll push right. Now it looks, like I'm in the root directory on the right, but I'm in the test folder on the left. That is not true. And the way we can test that is if I scroll down through my super long directory here, you'll eventually want to load. And look. And the right panel now says test, just like the left panel up at the top. Anyway, so what this cannot deal with, very unfortunately, is copying from like one folder or disk image to another folder or disk image on the same device. And that greatly limits its use. And this isn't really a problem, well, not Penultimate+ problem. And it's also not, I'm not going to complain about the CBM Commander, guys. I know that technically that would be a difficult thing for this program to support, but it's very disappointing that doesn't, to me anyway. That would be an excellent feature. So here I am just talking about what this does not do. Okay, I had to go back out, Shift minus. And you can also go into disk directories. Like here, I've got this supermon.d64 highlighted. So again, press Shift plus, and I'll enter a D64 file just as if it's a directory. And this is a disk. This was actually from Transactor magazine. And this also has a neat view file, I think in here somewhere. Yeah, run me text. So you see how it's got an S next to it? That means it's a sequential file. If you hit Shift return, it will view it as a text file. The Transactor magazine. The programs contained on this disk are just, you press return to page through. Okay. So this is a fine program, but it's way more useful if you have more than one disk drive. And I think a lot of people with a VIC-20, just if they have one disk drive, they might have like SD to IEC or whatever. I mean, I do have other disk drives. I'm just not really going to hook them up to my VIC normally. Okay. Moving on. Okay, we're reaching the end here. Utilities. This one is the ID changer. And this lets you reprogram your SD to IEC. Right now I've got it as device 8. If I want it instead to be device 11, I just type that in. The ID has been changed. So now I can load from comma 11, the disk directory, and list it here. Okay, and if I try to load from device 8, that does not exist. So it's useful if you want to reprogram your devices. I'm just going to set that back here to, it's currently 11, and I want it to go back to 8. Okay, and now it's back to device 8 again. So you might find that useful. Nice and easy to use. Okay, now here's an IEC port tester. So I don't actually know. I assume this means my IEC port is working. I mean, obviously we've been loading from it all video long, and it seems to be cycling through. I guess that means that's good news. I don't see any other progress here, so. Okay, there's also a dead test mode here, and I'll run that. So what this does is it goes through all your RAM, it tests, well, basically tests out your VIC-20. It takes a while to run, a few minutes. So after RAM 0's been tested, that should all turn to like check marks. Good. Now it's testing RAM 4. That happens to also be screen memory in this configuration. So that's why you can see that thing moving across the screen. And then it'll move on to the other RAM. So I'll just jump ahead and show you what it looks like when it's completely passed the test. But you might find that useful. Now, this is a super cool feature. This is like a secret feature. I'll turn off the VIC again. And now hold down the right button on the Penultimate while you power up. And let go. And it will automatically go into dead test mode. So that's a really cool feature. If your VIC-20 is too broken to start up and use the menu, you can still just try powering it up with that right button held down, and it'll go into dead test mode. And one last one down at the very bottom. Oh yeah, all the menus wrap around like this. Self-test. And that will actually test the Penultimate cartridge directly. The RAM built into it, the input-output, and then it'll even do a checksum on all your ROM, which is where all the games, all the programs are stored. The ROM's inside the cartridge. So if you've got reason to think that there's something wrong with your Penultimate+2, you can run that. I'm sure that that Rod at the Future Was 8-bit just runs that before he ships each one out to know it's working when it left. Okay, and we'll jump ahead to final result here. It doesn't take that long to run, but there we go. Okay, and just a few other things. So you notice down at the bottom of the page, F1 through F6 are dedicated to certain memory configurations. So probably the most common, if you hit F1, it's an unexpanded VIC, no extra memory, just regular 5 kilobytes, which is 3.5 free. Or press F5, and it does the maxed out extra 35K of RAM. But we looked at this briefly last video. Advanced memory configuration. Really, there's 3 different configurations that matter. Unexpanded, 3K, which is the smallest RAM expansion that was left. And then all these are pretty much equivalent from 8 all the way up to 35. Of course, 35 is the most RAM, but from a program perspective, they're almost the same. The reason those are all different is each one of these first 3 moves where the screen memory is and reconfigures where basic RAM is. It's really pretty goofy, but Commodore did that. So the RAM expansion is confusing. People often say that the VIC-20 only has 3.5K of RAM, but really it's 5K of RAM, 3.5 available for basic. 1.5 is dedicated essentially to video RAM or screen RAM, and the operating system working space. It would have been great if Commodore had just shipped the VIC-20 with 8K to start with, but it sounds like they wanted to cut corners to get down to a target price of $299. And part of how they did that was instead of 8K of RAM, they pulled 3K out, and that was a cost savings. That was, I guess, worth it to them to meet that target price and keep the margins high enough. It's that 5K isn't contiguous. There's actually 1K located at the very bottom of memory at address 0. 1024 bytes are there because the 6502 needs RAM at 0 page, the stack at page 1. That's the 0 page is the first 256 bytes. Each page is 256 bytes in 6502 talk. The stack is page 1, and the basic and kernel operating system use pages 2 and 3 for working space for storage. So those 4 256 byte pages are 1K in total. Then there's that 3K gap with no RAM. That was for cost savings. Then there's 4K of RAM, and that's used by default for the basic code storage and video memory. So that's the unexpanded. So that 3K expansion plugs that gap between the 1K and the 4K. And the 8K expansion doesn't plug the 3K gap. It puts 8K after the 4K. So these weird combinations of like 11K are plugging the 3K gap and adding 8K and so on. And that wasn't normally done in these RAM expansions. And actually the biggest normal RAM expansion would be 24, and then we add in the 3K plug. The extra 8K can be added up where ROM might normally go. And some really big games do use that, but it's not available to BASIC because, again, it's non-contiguous. So also, set RAM 35K, that's a 35K expansion in addition to the 5K built in. That's actually a 40K system. And then there's actually, what is it, a half kilobyte of color RAM, if you want to get really pedantic. Okay, so I hope that's cleared it up a little bit. Maybe I should do a video just about RAM, VIC RAM sometime. Well, that's why there's so many options possible. But like I say, normally you probably just need 0, 3, or go for the all-out 35. Okay, and the final thing, just in that settings menu, last time we looked at booting to a random game, but you can also make the cartridge boot to one of these other things, like to auto boot the first file on disk with 35K set, boot to regular BASIC, BASIC 4 with extra RAM, and you'll notice that these ones say 27K. Well, that's because this is BASIC 2 with 35K of RAM. BASIC 4 needs extra ROM space, so instead of 8K of RAM, it puts 8K of ROM there. Same deal with the Super Expander or VICMON. But if that's how you like your VIC to boot up, you can choose any of those. And this is where you can reset it back to boot to the menu if you just want it to go back to this nice menu. You know, boot to the Super Expander. You can choose it here. You'll go into the Super Expander, but also every time you power up, it'll automatically go here, and we'll have those like graphic commands available to us, for example. Okay, and there in the help screens, there's the C, press C for show the credits, and there's the credits. Again, designed and developed by Dave Cran at TinyMon Software, and produced and distributed by Rod at The Future Was 8-Bit, and some help from Misfit, and that's all good. Now again, have links if you want to buy this cartridge, or any of the other cool stuff The Future Was 8-Bit sells. Also check out TinyMon's blog, which is really good. Lots of good information there. Thanks again to Michael Doornbos for demonstrating the terminal feature. Check out his blog at imapenguin.com. Thank you very much to my patrons for their support. It's hugely appreciated. Thank you for watching, and we'll talk to you next time.